So the question asks about when you're in a car and you are driving, and all of a sudden you see a deer. And at this point, you're holding a coffee mug and you set it down while you decelerate right away. So it wants to know if the coffee mug ends up sliding um, while you are decelerating or not sliding. So this is the free body diagram for the mug. And basically, friction is keeping it accelerating with the car, while there is also normal force and gravitational force that are equal. So there is only a net force where the car is experiencing acceleration, and the mug basically follows the car. So our strategy with this problem is to connect kinematics to dynamics, because we know that acceleration is going to be constant across both of the kinematic and force equations. So the other strategy is to find the max static frictional force in this situation. So we can use kinematics here to solve for the acceleration of the car and the also needed acceleration for the mug when it basically sticks to the car with friction. And we know the initial velocity is 20 meters a second. And we know that the distance is 50 meters. So doing a little bit of algebra here, we get the acceleration to minus 4 meters a second squared. And we know that the mug has to basically match that sort of acceleration um, if the mug doesn't slip at all. So we can find the needed force for the mug to undergo this acceleration, and that would just be force equals mass times acceleration. The mass of the mug is 0.5 kilograms, and the acceleration is 4 meters a second squared. Um, this way we get 2 newtons. And we know that the frictional force must be at least 2 newtons here. Well, it should be exactly 2 newtons because static friction directly matches the force. So now we have this frictional force equation. Frictional force equals force in normal times the coefficient of friction. And basically, the normal force is mg because it is a flat surface. And this means that we do mg, m 0.5 here, multiplied by g 9.8. Then we multiply it by the coefficient of friction, which is also 0.5. And this number comes out to be 2.545 newtons, which is basically the max static frictional force. Any like more force than that, then the mug will start sliding. So knowing this, 2.45 newtons is greater than 2 newtons, which means that the cup will not end up sliding here. And that makes sense because the static frictional force can match the force needed of 2 newtons so that the cup will not slide. So, a common mistake with this problem is not connecting kinematics and dynamics. You need to use both kinematic and dynamics equations, or else you basically wouldn't be able to solve the problem. Another big problem with this question is using the wrong weight value because it gives many unnecessary values in this question, including the weight of the deer, which isn't very useful unless we were doing momentum and we collided with the deer. But those are basically two common mistakes. Thank you.